So I'm going to start recording just in case. So I just factored out the top and bottom. And the reason I factored the top and bottom is to help me visualize at what points there aren't continuous. In this one, we should be able to see that we're going to have a problem at -2 and at -1. So x cannot equal -2 or -1 in this case. Now, I know a lot of you are thinking, but Mr. Tobel, we could cross out the x plus 2. So we got x plus 3 over x plus 1. The reason I picked this question in particular is because this situation right here, even though I can cancel it out, which if we were doing a continuity question, like is it continuous, I would say that one would be a remove discontinuity. But we don't care what type of discontinuity it is. As long as it's not continuous, we know it's not differentiable. So even though I can simplify it and it will change the type of discontinuity, we don't care for, in this case, for the differentiability. So when the question is, where is this not differentiable? It is not differentiable at x equals, I should say, I guess, x equals 1, -1, and -2. Okay, does anyone have any questions on that one? Again, it's the same problem as we did yesterday at the end, but we kind of rush it. So I just want to make sure we have all the time we could get. Okay, let's go to the next one. This one is definitely something I could give you on the test. It would be a piecewise function.
Mr. Tobel, the Zoom just ended for a seed.
I figured so much. All I did is went over one problem at the end, and I also recording this, so you could check it out later.
All right, cool.
So let's do this one. As x is continuous, let's move this here. As is x continuous? Is it continuous at x equals 2, and is it differentiable at x equals 2? For the guys who are joining in a little late, what's happening is that if we know at this point it is not continuous, then we also know it's not differentiable. But it's a very important thing. It could be continuous, but it could be not differentiable. So we're going to see in this one an example of that. So the first thing is I want to test. Is it? Go ahead.
No, never mind. I was going to ask you to scroll up, but you scrolled up.
Okay. So for this one, we're going to talk about first, is it continuous? Now, this is from the last chapter test. Is it continuous? We check if it goes to the same point at the same place. And the key point here is x equals 2. So on the x is greater than 2, so the right side, we want to see if the limit exists at x squared. So as the limit, as x approaches 2 from the positive side, so from the positive side, so that's when x is greater than 2, so that's the top one here, it is x squared. I'm allowed to just substitute it. I'm recording the beginning part, but the beginning part was simply to simply review of the last question we did yesterday. So if you understood that, if not, I recorded it and you can just check it out later. It was only 5 minutes. So the limit as x approaches 2 from the positive side, x squared, x is greater than 2, so we're going to use that equation. Since there's no problem plugging in 2, we could just substitute 2. 2 squared, the limit is 4 at that point. We also have to check the limit on the negative side. So the limit as x approaches 2 from the negative side, so that's less than 2. So that's this equation on the bottom. X plus 2. In this equation, we have no issue substituting 2. It doesn't cause any undefined or imaginaries. 2 plus 2 equals 4. So because the limit matches at the same point, yes, it is continuous. Now my question is it differentiable? So the points physically match at x equals 2. We want to see if the slopes match at x equals 2. And I'm purposely going to use the equation on the top right over here because we did a lot of practice when we were learning that x plus h. So I want to balance it out and use this one instead for today, just so we have practice with this equation also. So we need to see if the limit or the slopes are the same. So we're going to start off by the slope or the limit as x approaches. Remember, a could be used for any number. So in this case, a is 2 from the positive side for the derivative. So I'm going to plug it in as f of x minus f of 2 over x minus 2. Okay, so let's plug in the 2 for this one. It is x squared. So it's going to be x squared minus 2 squared over x minus 2. Now, my goal is to make the x into a 2. If I make it a 2 right now, I will get 2 minus 2 on the bottom, which is 0. And I can't have a 0 in the denominator. So at this moment, I cannot substitute x equals 2. But on the top, I have a difference of squares. So because I have a difference of squares, I'm going to do x plus 2, x minus 2 over x minus 2. These are the same, so I could cross it out. Send the page a little bit. So then I got x plus 2 as the limit x approaches 2. At this point, I don't have a problem plugging it in. So my slope happens to be here 4. The fact that it matches the point is incidental. So 4 is my f prime at 2 for this one. It could also be written as the y prime and all the other notations, but I'll keep it to there. So while this is your y value, this is your y prime value. So we just checked the positive side. We're going to follow up with the negative side. We just checked the positive side. We're going to have to check the derivative from the negative side here. So it's x plus 2. So let me just write the equation. The limit as x approaches a, f of x minus f of a over x minus a. Remember, a is for any particular point. The particular point we're using is 2. So the limit as x approaches 2 from the negative side now, f of x minus f of 2 over x minus 2. We could plug it into the function. So it's x plus 2 minus 2 plus 2 all over x minus 2. If I replace the x with 2 right now, I'll have a 2 in the denominator. That's not okay. So I have to simplify in some way. On the top part, I could rewrite it as x. So this is 4. So x plus 2 minus 4 would reduce to x minus 2 over x minus 2. Hey, that's exactly the same on top and bottom. That reduces down to 1 over 1. If you don't remember from our limit rules, a limit as x approaches anything, in this case 2, of a constant function is going to be the constant. So in this case, it's just 1. So 1 is y prime. Now in this case, while 4 is y prime over here and 1 is y prime over here, these do not match. Because these do not match, that tells us something. That means it is not differentiable. I'm trying to scroll up here with this pen. So is it differentiable in this case? No, it is not differentiable in this one. It is continuous, but is not differentiable here. Okay. Anyone has any questions on what just happened? All right. I do want to go to the next page. So I'll give it like 10 seconds if you want to pull out your phone and take a picture if you're still copying. Okay. Let's go to the next page. All right. This is another type of question. This would kind of fit more with the 2.4 stuff, but it's totally relevant here. So when we found the tangent or the slope at a point, we're still finding a slope value. But that tangent line might have an equation attached to it. Not might, it does have an equation attached to it. So with that slope value that we're going to find, we're going to also find the equation for it, and we're going to find the equation for the normal line, which maybe you've seen in physics. I don't know if they talked about normal lines, but if not, we'll talk about it together. So your question is on the left. For y equals x squared plus 4x, at x equal 1, find the curve of the point, or I should say, find the slope of the point, not curve. Slope of the point, the equation of the tangent, and the equation of the normal line. Now, the curve of the point and the slope of the point is the same thing, but because I'm very particularly talking about making equations, I'm just going to use the word slope. Once again, we're going to use this top right formula just so we get a little bit more practice with it, because we did a lot with it, x plus h1. So I just want to make sure we balance it out with this one. Okay, so whenever we find a derivative at a point, or the slope at a point, or the tangent line at a point, that's always been the same thing the whole time. So for part A, we're doing the thing that we've been practicing this whole section. So what we're going to do is for the limit as x approaches a, I'm going to change that to the limit as x approaches 1, f of x minus f of 1 over x minus 1. Going to plug it into the equation over there. So I got x squared plus 4x minus, I'll put this in parentheses, 1 squared plus 4 times 1 all over x minus 1. At this exact moment, if I replace the x with 1, I would get the undefined on the bottom. So I can't do that yet. So let's simplify the top. Hopefully we can neutralize some things. X squared, this is going to be a plus 4x. And then we have 1 plus 4, but that's being subtracted, so negative 5.
X plus 5, x minus 1. It'll
Yeah.
root 2.
Good. So the top will be reduced down to x plus 5, factored out, x plus 5, x minus 1, all over x minus 1. Hey, we could cross these out. Funny how it works out like that. So we got x plus 5. Remember, the limit is x approaching 1. At this moment, we don't have an issue plugging it in. So we end up finding the slope at this point being 6. You could call it the m. You could call it the y prime. You could call it the f prime at 1. All these names are valid. I'm going to use m in this case because it's going to be significant for part 2 and 3 here. Okay. So we just did this, happens to be 6. Part B, find the equation or make the equation for the tangent. So remember, this slope makes an actual line off the curve. Like it's a curve, and this is this line that pops out of it. So this line has an equation, just like any other line has some algebraic equation. Now, I know instinctively, and if I was learning this instinctively, I would want to write it in y equals mx plus b form. But we could just use a point and a slope and use the point slope form to make our lives easier. So we're going to use the point slope form. If you don't remember what the point slope form is, it is y minus y1 sub 1 equals mx minus x sub 1. In case if you don't remember. All right, so we have an m, that's good. We need a point. So we have to find a point. And there's only one thing though.
Wait, when it says y, that means y2, right?
No, because in slope, because you want this to be a final equation. So kind of like in y equals mx plus b, at your final answer for your equation, y and x stay variables. This y and this x will stay the variables at the end.
Okay.
Okay. So we need an exact point though for the equation. So we know the slope at x equals 1 is 6. So what I also need to find is the coordinate point. So I know I'm using x equals 1. So I need to find the coordinate point. That's very simple. You just plug it into the original equation to get your y. Remember, the 6 we found is y prime. What we plug in here is going to get you your y value. So where is it actually on the graph? So plug in 1, very easy. 1 squared plus 4 times 1 equals y. Y ends up equaling 5. So for this curve, it exists at 1 comma 5. Or I should say the line passes through 1 comma 5. This point,
I'm having trouble seeing that equation for the y equals 5. What does that say?
y equals, the original equation is this one up here. So I just plug in 1. So y equals 1 squared, because this is x, plus 4 times 1, because this is x. Is that a little clearer? Or was that not what you're talking about?
No, that's clear. Thank you.
Okay. So we have y equals 5. We have x equals 1. This is y1, x1. And we have a slope, which is 6. All we have to do is plug it into our point slope form. You could spend time after plugging in a point slope form, change it into y equals mx plus b. I think that's wasted effort. This is also a valid equation. So it's y, we're going to plug in 1, so, or y, 5. So y minus 5 equals the slope, which was 6, x minus the x value, which was 1. This, by the way, is an equation of a line. This is the equation of the tangent line. So right here is your answer for B. Okay, anyone has any questions, just plug it into points and everything like that. What is the equation of a line? All right, so a normal line, I don't know if you went over this in physics. It might have been called the normal vector, I imagine. But the normal line is perpendicular to the tangent line. That's the key point. The normal line is perpendicular to the tangent line. How does the slope change for a perpendicular line? Does anyone remember?
Negative inverse?
Good. We're going to do the negative, not inverse, negative, starts with R.
Reciprocal. Yeah, reciprocal. There we go.
So we're going to use the negative reciprocal. What's really good about point slope form is I don't have to find a new y-intercept as if I were use mx plus b. All I have to do is change the slope into the negative point, the negative reciprocal. The point stays the same. So my answer for C is just y minus 5. The y coordinate is still the same. I need a negative reciprocal of 6 over 1. So that's negative 1 over 6. X minus 1. My x coordinate stayed exactly the same. So we have minus 5. This is, and then that's it. We have our same, we have the normal line right here. And this is why I highly suggest keep it in the point slope form. Because if you put in y equals mx b form, we got to find the new b. That's more work. Don't waste time. Use it in point slope form, okay? Does anyone have any questions on these questions? All right. I will dismiss you soon. I just want to talk about something. On the Google Classroom, I'm going to share after this. Where is it? Okay. So here is the solution, or the answers to problems from the textbook. This is from the 3rd edition. So the page number might be different, but the question number should still be the same effectively. So the page number might be different, but the numbers will be the same. So like if I gave you number 1, here's the answers. I'm going to post this in Google Classroom. But what I'm also going to post in Google Classroom is this is the solution manual. The solution manual shows you the step to the answers. So for example, number 1, it shows you the equation you use and all the steps you plug in, does the math. It's going to cut some like paces, like it does it quickly. It wouldn't show as much work as if I was teaching you the work. But it shows you the steps that should happen around in the middle. So you see how your answer is negative 1 over 4. That's the answer to this question over here, negative 1 over 4. So I'm going to share both of those on Google Classroom. And I'm also going to point out what questions I would suggest you guys do for review. So the questions.
Posting the notes for the chapter.
Sure, but you should be copying on notes. Do you really need the notes? I'm happy to post what I did today, but.
Okay.
Okay. But anyway, so here's the thing. I also want to talk about this. I talked about how the question would look like, but I haven't actually done it. This question, if you see over here, it asks you to match the graph with the function. So over here, you have like this parabola. It looks like x squared. So it's up to you to figure out, hey, where should that one match up to in the derivative? So we want to take the estimates of these things. So let me talk about how you would do it. So on the left side, you could say the curves. I'm going to try to turn on annotation here. You could say the curve over here is definitely negative. So you know your value should be negative here in the y prime function. Over here, it's 0. So you know at 0 should be 0, the y prime. And over here, it's positive. The slope is positive. So on the left, it should be negative. In the middle is exactly 0. On the right is positive. Let's look up here on the question. So this one, while being exactly the same as the original, this is positive over here. So that definitely doesn't match our y prime. Over here, it's negative slope that gets closer and closer to 0 as it approaches 0. Then is at 0, the y prime. And it goes back to that positive slope. And that matches what we said here. It should be negative in the beginning, then it gets 0, then it gets positive back up. So what we have here, number 14, would match with this first one here. So these two match together. Okay, let's talk about this one. Over here, the straight line. Let's see. So this one right here is a straight line. So that means the slope will be matching what the line is because it's straight. So the slope should be consistent all the way through. So it's a consistent flat number. And wait a second. This is the, oh, this is the y prime. I don't like how they formatted it, but basically if this one was this one, if you had this straight line, your y prime would be a flat line. It looks like a positive slope, so you could say it's a flat line probably at like 1 or something, maybe like 2. So it would look like this. I just realized they're giving me in reverse. So this one should be the derivative of another one. So let me actually do it properly, my fault. So this one over here, let's say this one. So your negative slope over here, negative slope over here, you have like a 0 slope over here, kind of looks like at -2. You have a 0 slope over here, it looks like you have a, at 0. You have a 0 slope over here, you have a, at +2. There's a positive slope over here, there's a negative slope over here. So you're kind of like looking at like sectors, particularly where the zeros are. So it should be 0 at -2, 0 and 2. So look back here. Should be 0, like I said, between -2 at 0 and 2. Oh, we have 2 possibles here. So these ones definitely are in it. So then we're going to look in the in-betweens. It starts off negative, then it turns positive. So here, look at this, negative, then it turns positive, goes back to 0. The slope over here is negative until it goes back here at here. It goes back to positive. So I would say this one matches with 16, which they said it did. So basically, that's what you're kind of looking for. Remember, these are just estimates. So you're kind of like saying, oh, it kind of looks like that. It should be these points. So I just want to talk about the actual thought process you want to do. So after the Zoom call's over, I'm just going to look at the problems again, pick the ones I would give on a test, and then post that in Google Classroom with these answer solutions. Just type in the chat here if you're here. And then after you type that, you're free to go. That'll be your attendance or exit ticket. And if you want to stay over to have a little questions, I'm happy to take those too. But otherwise, no problem.
Yeah.
Otherwise,
Bye.
everyone have a wonderful day. Good.
Okay, bye.
Have a good weekend, Mr. Doble.
You too, my man.